Implementing FoxPro's scatter and gather member in Delphi. Implementing FoxPro's scatter and gather member in Delphi. Delphi Developer February 2001 Copyright Pinnacle Publishing Incorporated. All rights reserved. Implementing FoxPro's scatter and gather member in Delphi. Steve Zimmelman technology is always moving forward, usually leading to more productive development. However, there are times when reaching into the past can be helpful, too. Replicating or comparing table data in FoxPro was a fairly simple task. Steve Zimmelman argues that perhaps this technology is worth reaching back. FoxPro's scatter and gather commands were always useful for copying records from one table to another, comparing data, or record replication among multiple tables. For those of you who haven't had the pleasure of working with FoxPro, the scatter and gather commands work like this. Suppose you need to copy a record from one table to another. You'd do something like, select table 1 scatter member, select table 2 gather member. The scatter command reads all of the fields for the current record and places them into memory variables. Each variable that's created with scatter has the same name as the field from which it originated. The gather command updates the current record with memory variables that have names that correspond to the fields. So if table 1 has the field's name, address, and phone, and the variable's name, address, and phone exist, then when the gather command is executed it updates the record with the value stored in those variables. There are many ways to accomplish this with Delphi, but there's nothing natively supplied in the VCL that works at the T-dataset level. In my latest application endeavor, I had a need for the old scatter and gather functionality. So, I ended up writing my own scatter member and gather member methods. Creating the scatter and gather functions. Both of these methods are wrappers for an object called tMember. tMember maintains a dynamic array of a record called Memvar fields. Each element of the Memvar fields array contains the field name, data type, and value of a corresponding field in a data set. So each instance of tMember contains the data from a single table record. Type Memvar field equals packed record field name, string, value, variant, data type, tfield type, and tMemvar fields equals array of tMemvar field. When the scatter member function is invoked, it creates an instance of tMember and returns a pointer to that instance. When tMember is created, it loads the fields from the designated data set into the array. To avoid dataset duplication, each instance of tMember is identified by its dataset property. Before a new instance of tMember is created, a search is performed for a matching dataset in all existing instances of tMember. If one is found, the matching instance is reused. If not, a new instance is created. Function scatter member, dataset tDataset, tMemvar, begin if dataset equals nil, then raise exception. Create dataset cannot be nil, / reuse the object if it already exists. Result equals find member object, dataset, if result equals nil, then begin result equals tMember. Create dataset, and else begin result. Load field data, and constructor tMemvar. Create dataset tDataset, begin fflds equals nil, f dataset equals dataset, if f dataset equals nil, then begin raise exception. Create dataset cannot be nil, and if f scatter list equals nil, then f scatter list equals tlist. Create f scatter list. Add self load field data, and procedure tMemvar. Load field data, var I, integer, begin if not dataset. Active then dataset. Open fflds equals nil, / set the length for the record array. Set length, fflds field count, for I equals 0 to, dataset. Field count 1, do begin with dataset. Fields I do begin fflds I. Field name equals field name, fflds I. Value equals value, fflds I. Data type equals data type, and normally when you create an object, it's necessary to free the object when it's no longer needed. But the unit that contains the code for this object maintains its own internal list of tMember instances and destroys them automatically when the application closes. So you can free the objects when they aren't needed, or ignore them and let the unit take care of itself. To manage the tMember objects that are created for each scatter member usage, I add each new instance of tMember to fscatterList, a type of tlist. The unit that handles all of this code contains initialization and finalization sections. The initialization makes sure fscatterList is set to nil. This is done so that the create method of tMember can interrogate the value of fscatterList and create an instance of it only when necessary. This keeps the resources that the unit requires down to a minimum. The finalization section spins through the list and frees any T-member objects it references. Procedure free scatter list, var I, integer, begin if f scatter list equals nil, then exit, try for I equals f scatter list dot count 1, down to 0 do begin try Memvar, f scatter list dot items I, dot free, except end, and, finally f scatter list dot free, f scatter list equals nil, and, initialization f scatter list equals nil, finalization free scatter list. To avoid potential access exceptions, T-member removes itself from the f-scatter list when it's freed. You'll also notice that if all items have been deleted from f-scatter list, the list is freed. Again, this is done to keep resource usage down. Destructor Memvar.destroy, var I, integer, begin / clear the array elements. FFLDS equals nil, for I equals 0 to, f scatter list dot count 1, do begin try if, T-member, f scatter list dot items I, dot dataset equals f dataset, then begin f scatter list dot delete, I, and, except end, and, if, f scatter list dot count equals 0, then begin f scatter list dot free, f scatter list equals nil, and, inherited, and, after scatter member has been used to place a dataset in memory, that specific T-member object can be accessed from any unit in the application. Because each instance of T-member is stored in f-scatter list, it can be considered a global object that can be accessed by any unit that has a reference to the member unit in its uses statement. The method gatherMember is used to put the data into the same table from which it originally came or, if necessary, a different table. GatherMember spins through the fields stored in the T-member object and updates the target record with fields that match the field name and data type. So the fields in the T-member object don't have to be an exact structural match to the target. Fields that don't match the field name and data type are ignored. In addition, T-members field values can be modified before using GatherMember, so you can replicate slightly different data should the need arise. GatherMember is implemented in two flavors, using the overload directive in the method declaration, procedure gather Memvar, source Memvar, target T-dataset, options T-gather options, overload, procedure gather Memvar, source target T-dataset, options T-gather options, overload. The only difference between these two methods is the first parameter. The first implementation uses the actual T-member object reference. The second uses the dataset that was used to create the instance of T-member. Other than that, they're both identical. In fact, the first implementation actually calls the second. There are also some options that allow you to control how the gatherMember method gathers the data. You can replace or append data, issue a post, or free the object once the gather is complete. If no options are present in the parameter, the default is to replace the target's dataset record and leave it in edit state after it modifies the field data. tGather option equals goReplace, goAppend, goPost, goFree. tGather options equals set of tGather option, procedure gather Memvar, source Memvar, target tDataset, options tGather options, begin if source equals nil, then raise exception. Create source Memvar object cannot be nil, gather Memvar, source.dataset target options, and procedure gather Memvar, source target tDataset, options tGather options, var I, integer, I index, integer, memobj, tMember, fr, tMember field, begin memobj equals. Find member object, source, if memobj equals nil, then begin raise exception. Create source dataset plus source.name plus has not been scattered, and if goAppend in options, then begin target.append, and else begin if not, target.state in dsEdit dsInsert, then target.edit, and for I equals 0 to target.fieldCount1, do begin I index equals memobj.findFieldIndex, target.fields I.fieldName, if I index equals 0 then begin if, target.fields I.dataType equals memobj.fields IIndex.dataType, then target.fields I.value equals memobj.fields IIndex.value, and if goPost in options, then target.post, if goFree in options, then memobj.free, and putting the new functions to use here are a couple of examples of how these methods can be used. Procedure My example 1 copies field data from table 1 and appends a record to table 2 with the data from table 1. The options parameter goPost and goFree instruct the method to issue a post to table 2, then free the tMember object. Procedure My example 1, var memobj, tMember, begin memobj equals scatter member, table 1, // append a record to table 2, post it, / then free the t-member object. Gather member, memobj table 2 go append go post go free, and procedure my example 2 copies field data from table 1, appends a record to table 2 with the data from table 1, then modifies the name field before appending a record to table 3. In both gather member instances, the record is posted. The last also frees the t-member object. Procedure my example 2, var memobj, t-member begin memobj equals scatter member, table 1, // append a record to table 2 and table 3, post it, / then free the t-member object. Gather member, table 1 table 2 go append go post, / change a member field value before appending / a record to table 3. memobj field value name equals Steve Zimmelman, gather member, table 1 table 3 go append go post go free, and